So I have a video where I made this collet stop for my R8 collets, and quite honestly the video is really horrible. I'm probably going to pull it down. I don't know, maybe I'll leave it there in case people do want to see the process. I was experimenting with some different techniques for camera placements and shooting, and it just came out all kinds of bad. So what I figured I'd do is actually go in depth here and talk about the how and the why. So I'm going to put this one aside for just a minute. This is what I made, and here's a traditional collet stop. There's a threaded end that fits in the back of these collets that you can thread them into. And what this does, for those who aren't aware, is it gives you a repeatable depth stop. So if you can see inside of there, we've got the end of the collet stop. Now you can adjust how far in that goes by loosening this nut and driving that further forward or more to the rear. And that way, when you have your material in the lathe and you have to do either repeat insertions and removals of that material or making a large number of the same part, this gives you a repeatable surface in the rear to register against. So that works great for something like this. You can see I have a very large diameter in here. Okay, but what I ran into is I needed to create a large number of very small parts, this part here, for a customer. Okay, in order to create that large number of parts in volume, I needed to have some way to repeatably reference something. Once it's this small, there's nothing to grab onto except this tiny barreled center here. So let me put this aside. Okay, here's a piece of the raw stock I started with. This is 303 stainless, by the way. So in a larger collet like this, no problem. If I have something large I want to put in there and register, this couldn't go very deep into the collet. So here's the actual collet I used, and I needed to set in just a small amount so I'd have material on the outside that I could, create my small part from. So I ran into a couple problems. The collets aren't this size all the way down, as you can see. There is a depth about to here that this bore diameter goes through, and then it opens up larger inside. With a collet stop like this, as you can see, it's larger than the hole in the collet. So this hits the back side of the collet in here, and I can't push up any further. So this works fine for larger material, but when you have something very, very small that you need to put in here, this is too big. And I didn't want to turn this down. This is a nice steel part. I wanted to keep that. So I'll keep this as is. So that led me to making this one. So what I made first was just this sleeve. Okay? And this was just made out of some scrap, some steel that I had lying around, and then threaded it to fit in the back of the regular 5C collets. Okay, now I can take this aluminum cylinder that I turned down to fit this diameter. The only thing that was critical on here dimension-wise, and this is mentioned in my video, is of course this thread interface here, and to be sure that the external diameter is no larger than the threads in the lathe. All right, so now I've got my adjustable stop in here. I took a piece of aluminum stock, like I said, turned it down to size, and now this end I turned down smaller than the diameter of this center. Now this did a couple things. Obviously, I can insert this in here, and I have any degree of depth that I want to set, right from the surface down in. So now I'm going to have a repeatable overall length for every part that goes in here. All right, so I can set that. But what I also did, I'm not sure if you can notice it, is this is actually center drilled and recessed just slightly. And the reason for that is all of these parts were parted off with a parting blade, and it leaves that small bump in the middle on pretty much every part. I'm not using high-speed steel, it's a carbide blade, and it just tends to leave that little bitty bump right there. No matter how much I dial things in, one of the two pieces gets it. So if I were to use a flat-faced collet stop, what this is going to do is it has the ability to pivot around there and not necessarily sit true when it's in the collet. So I machined in a flat surface and a recess so that when this is in here, it's turned down to that smaller diameter, by the way, before it goes in here. But when this is in here, if there is a bump in there, it has a recess to set in to give me a flat surface, so now there's no spin. I don't have a pivot point in here. So now I can go ahead and put my piece in, tighten it down, Okay, and now I have a repeatable stop to my stock into every time. So as I take this out, all right, I have the same length every single time, so I never need to change any of the information on my DRO. So when I'm turning these down, what I'm able to do is take the piece out, put a new piece in, clamp in the collet stop, and then just turn this down to the right diameter. So very, very quickly, I can just pop this out, put the next one in, turn the diameter down, pop this out, put the next one in, turn the diameter down, etc. So I do these in batch. 50 an hour, I think, is what I was cranking out, turning down the diameters on these. So then I'd flip it over, dial in the smaller diameter size, because I still have this center that I've turned down, set to that depth, and now I can dial in this end. So I basically was able to cut this end and this end extremely quickly, but with a high degree of accuracy. All the surfaces on here are very critical dimensions. This depth here has to be a very specific height on this center ring. It's a very specific diameter. The length of each threaded portion is extremely specific, even down to specifying the last 3/4 of a millimeter on here with some very specific requirements from the user. So what I had to do really was build something that allowed me to do this in volume. You know, to get accuracy like this isn't necessarily challenging, it's time consuming. It's attention to detail. So anything you can do that can speed up your repetition is going to help you extremely. So as this goes in, collet sits in the lathe, collet is threaded down to a particular location, the lathe cinching is set the same every time. So as I put these pieces in and out, I'm coming out within just a few thousandths of length overall, which is fine for the tolerances of this piece. But thought I'd share this to show you the reason how and why for this stop. So in addition to what I've done here, I'll show you a couple of things that were considerations. So as I created this blank, obviously this is just aluminum. It's very cheap to use, very quick to manufacture, and I almost always have some pieces, short stock lying around. So in addition to the recess and divot I made in here, should I need to do work on a very small threaded component, what I actually can do, and I'll be doing that because I have to do some more work on similar pieces of these, is turn down another piece that fits in here. I probably just reuse this one for right now, but I will drill and tap that center. This is an M5 on this piece. So then what I'll be able to do is when this is in here, I'll be able to thread this into the collet stop. And what that will do is allow me to thread right up to this surface. So then when it's inside of my collet, it'll be threaded in here like this. And this outer ring will be slightly larger than the diameter of the pin here, so that when the collet closes, it'll be able to close right on that outer ring and allow me to work some very fine details, that last 3/4 of a millimeter I was telling you about. So the versatility of this compared to the static nature of this really drove me to build my own collet stop. You know, again, I can set them to any distance. I can make them very quickly, very job specific. This one, when it's finalized, will actually be for this customer's part, and it goes in the drawer. And I keep sample parts, notes, any tooling that I made for a customer in customer specific locations. So when they want more, I can pull them out and you know, replicate the work very, very quickly. So this is just a quick overview of that horrible video that I made. I hope you like it. The video is still there. If you want to go look at it, it's long and boring and horribly made. But go check it out. It goes over the manufacturing process that I did with this piece primarily. A lot of lathe work, a little bit of mill work. So go take a look at it. Hopefully you can get something out of it, but really this is the how and why of everything. So thank you.